Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. In this present video, I would like to discuss the problems in the question bank, and the topic is the partial differential equations solutions. And it is comes under module number 3 of the subject differential equations and vector calculus. And now we see some problems and their solutions. And see the first problem. Solve the differential equation xp plus yq is equal to 1. So we know that before going to solve, I will give some notations in the partial differential equations. So P means what we know that it is dou z by dou x, and Q is equal to dou z by dou y. And it is a Lagrange's linear equation formation. So if the given equation is in the form PP plus QQ is equal to R, where PQ are functions of x, y, z, then we have to write the dx by P is equal to dy by Q is equal to dz by R. And from this you can take any two and get the solution, and the solution will be in the form phi of the constant C1, C2 is equal to 0. So this is the method of finding the solution of the given equation. So here we consider the equation xp plus yq is equal to 1. So if you compare this equation with pp plus qq is equal to r, capital P is equal to x and capital Q is equal to y and r is equal to 1. Then the Lagrange subsidiary equations are dx by x is equal to dy by y is equal to dz by 1. 1 is r, dz by r. Now I am taking the first two relations and equating the first two, dx by x is equal to dy by y. So I am taking integration, what we will get, dx by x is equal to integral dy by y plus the constant C1. Or what I can write it as integral dx by x, log x plus log y is equal to log C1, or log xy is equal to log C1, or xy is equal to C1. It is the first two relation solution. The first two relation, I am considering first and second relations. Similarly, I consider the second and third, that is dy by y is equal to dz by 1. I am taking integration. Integral dy by y is equal to integral dz by 1. So log y is equal to integral dz z plus c2, or I can consider it as log c2 also. So log y minus log the c2 is equal to z, or log m minus log n, log m by n is equal to z, or y by c2 is equal to e power z, or c2 is equal to y by e power z. So I am concentrating on the constant, c2 is equal to y by e power z, and here c1 is equal to xy. Therefore, the complete solution phi of c1 comma c2, that is xy comma y by e power z is equal to 0, which is the required solution of the given partial differential equation. So we have to consider the subsidiary equations, and we take either 1, 2 or 2, 3. 1, 3 we take two relations and then you solve the equations and to get the solution in the form phi of C1 comma C2 is equal to 0. And see the next problem. This is also in the form PP plus QQ is equal to R. It is also in the form PP plus QQ is equal to R, where P, Q, R are functions of XYZ. So here what is capital P? It is root X, and capital Q, that is root Y, and capital R. What is capital R? This is root Z. Then the Lagrange's equations are dx by P is equal to dy by Q is equal to dz by R. Or how I can write, it is a dx by P means root X and dy by root Y is equal to dz by root Z. So I am considering the first two on taking dx by root X is equal to dy by root Y. In the second case, it is dy by root Y is equal to dz by root Z. Now clearly x variables on dx side are integrating integral x power minus half dx is equal to integral minus half dy plus c1, or x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1, y power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c1, or 1 minus half, that is half, or 2 into x power half is equal to 2 into y power half is equal to c1, or 2 on taking outside, x power half minus y power half is equal to c1, or x power 1 by 20 root x minus root y is equal to c. That is another constant, because c1 by 2, that will give another constant, some k1. So what is the first solution? Root x minus root y is equal to k1. This is the first solution. Similarly, we find the second one. Similarly, what is the second one? dy by root y is equal to dz by root z. So on taking integration, y power minus half dy is equal to z power minus half dz plus c2. So what is the integration? Y power minus 1 by 2 plus 1 by minus 1 by 2 plus 1, z power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c2. So 1 minus half, so 1 by 2, 2 into root y is equal to 2 into root z plus c2, or 2 root y minus 2 root z is equal to c2, or root y minus root z is equal to c2 by 2, that is k2. That is another solution. Therefore, the complete solution, here also you can write the complete solution. The complete solution is given by phi of, what is the first solution? Root x minus root y. Root x minus root y. Second solution, root y minus root z is equal to 0 is the required solution of the given partial differential equation. So all are comes under the same methodology. Here also, solve the partial differential equation. It is also in the form PP plus QQ is equal to R, where P is equal to, what is P? Y square, and Q is equal to X square, and R is equal to X square, Y square, Z square. So now how to consider the Lagrange's subsidiary equations are dx by p is equal to dy by q is equal to dz by r. So here what is p? Dx by y square. What is q? X square. So dy by x square. Dz by r. R is x square, y square, z square. Now from this you take first and second and take second and third to get the solution. So I am taking first and last. I can take dx by y square. First and second I can take. I'm taking dx by y square is equal to dy by x square. On cross multiplying, x square dx is equal to y square dy. X variables on dx side and y variables on dy side. So I'm integrating. Integral x square dx is equal to integral y square dy plus c1. Or x cube by 3. Integral y square dy, y cube by 3 on right and left side it is minus y cube by 3 is equal to c1. This is the first solution. Similarly, you find the second solution by considering first and last or second and last dy by x square. Dy by x square it is equal to dz by x square, y square, z square. And considering the last two, dy by x square is equal to dz by x square, y square, z square. So x square also gets cancelled. So y square dy is equal to 1 by z square into dz. So integrating both sides, integral y square dy is equal to integral z power minus 2 dz plus another, you will get the constant also c2. Or what is the integration for y square dy? That is y cube by 3. This is 1 by z square dz, z power minus 2 dz. Z power minus 2 plus 1 by minus 2 plus 1, or it is minus 1 by z plus c2 is equal to y cube by 3. Or what is another solution? Y cube by 3 plus 1 by z is equal to c2. This is the second part of the solution. Therefore, what is the required solution? The complete solution is given by phi of c1 comma c2 is equal to 0. Phi of x cube minus y cube by 3 comma y cube by 3 plus 1 by z is equal to 0, which is the required solution of the given differential equation. So here all are comes under Lagrange's equation, and the equations can be solved by taking the relations from dx by p is equal to dy by q is equal to dz by r, and all are coming here. The variables x variables on dx side and y variables on dy side. If it is not possible, then we have to take the multipliers then and we have to solve. That will seen in the next module. And also I will solve some more problems, simple problems. Another example, take example number 4. Solve p plus q is equal to 1. Similar problem, solve p plus q is equal to 1. So what is p here? So the general format is small p capital P, small q capital Q is equal to r. So what is capital P here? 1, and capital Q also 1, and r is also 1. Then what is the equations? What are the equations? Lagrange's equation, dx by p is equal to dy by q is equal to dz by r, or this is dx by 1 is equal to dy by 1 is equal to dz by 1. So I'm taking first two, dx is equal to dy, and integrating integral dx is equal to integral dy plus c1, or x is equal to y plus c1, or x minus y is equal to c1. That is the first solution. X minus y is equal to c1. Similarly, on equating the second and third relations, dy is equal to dz, or integral dy is equal to integral dz plus c2, or y is equal to z plus c2, or y minus z is equal to c2. That is the second relation. Therefore, the complete solution is given by phi of x minus y comma y minus z is equal to 0. So, on solving this by formatting this equation, by using the elimination of arbitrary function, we can get this equation, right? Similarly, I will do the last example. The problem number, example number 5. Solve a minus x into small p plus b minus y into small q is equal to c minus z. It is also similar model because it is in the model small p plus capital P is plus small q plus capital Q is equal to R. So what are the subsidiary equations? The Lagrange equations are dx by p is equal to dy by q is equal to dz by R. So what is p here? Here capital P is a minus x, capital Q is b minus y, and capital R is c minus z. Or how I can write dx by a minus x is equal to dy by b minus y and dz by c minus z. So, now equating the first two, what we will get now? Dx by a minus x is equal to dy by b minus y. And taking integration both sides, integral dx by a minus x is equal to integral dy by b minus y plus log c1. What we will get here? Log a minus x, and a minus x derivative minus 1. So, minus log a minus x, the integration, integral 1 by x dx. Integral minus 1 by x dx like that. So, minus log x dx. Log x. And here it is minus log b minus y, and this is plus log c1, or minus log a minus x plus log b minus y is equal to log c1. So it is log m minus log n notation. So log m by n, b minus y by a minus x is equal to log c1, or b minus y by a minus x is equal to c1. That is the first part of the solution. Similarly, we equate the second and third, that is log b minus y. Similarly, consider what we have to consider, dy by b minus y is equal to dz by c minus z. So, on taking integration both sides, integral dy by b minus y is equal to integral dz by c minus z plus log c2. So, what is the integration? So, 1 by b minus y. When you differentiate b minus y, you get minus 1. So, minus is not there. So, on multiplying with minus, minus log b minus y minus log c minus z plus log c2. Or what you can write is log b minus y, minus sign is already there. And I am writing minus log c minus z this side plus log c minus z. This is equal to log c2. or log C minus Z by B minus Y is equal to log C2, or C minus Z by B minus Y is equal to C2, and this is the second relation. So now the complete solution. Therefore, the complete solution is given by phi of, what is the first relation? What is the first constant? B minus Y by A minus X. And what is the second one? C minus Z by B minus Y is equal to 0, and which is the required solution of the given partial differential equation. So here we have solved 5 problems. All are Lagrange's linear equations, and the method we have applied is the Lagrange's subsidiary equations, and on taking the equations, considering the equations, we will get 2 relations, and from the 2 relations we write the complete solutions in each case. Suppose if the variables are not separated, then we have to go for the multiplicating Lagrange's multipliers method. That means you have to choose some multipliers and then integrating to get the solution. That will come in the next part that we'll see in the next model. So these problems have been taken from the question bank of the course Differential Equations and Vector Calculus. And the regulations are BT23 and it is published by IARE. And thank you for listening. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.